Alright, so I'm going to recommend pausing the video here and reading through the question, having a good understanding of it, and maybe even trying it out yourself. So we're going to go forth, assuming you've done so. Alright, so the algorithm that I like that solves this problem is, we're going to talk about it from a high level. First, we're going to create a main master array with 26 slots corresponding to each character, each lowercase character in the alphabet. Then we're going to create, as we iterate through each word, we're going to create a temporary array that we are going to update each time we see a letter. So the second slot in that array, as we iterate over B, so as we iterate over the characters, we update the second slot in that array from 0 to 1. When we're done iterating through that word, we then compare our temporary array to our master array. And it's pretty easy from there. So maybe that doesn't make a ton of sense for now, but let's just jump right in because it'll be much clearer once we actually code this thing. So let's call this one common chars, and I'm going to use a lot of ES6 stuff, like this arrow function and for loops. So if you don't know how those work, maybe just pause the video. But I'm just going to keep going without getting into too much detail about those. All right, so let's create that main master array. Let's just call it total. And we're going to create those 26 slots that I talked about. We're going to fill those with a big number. Let's just do 100. And the reason for that will be clear later. Basically, when we go to compare our temporary array to this array, we're going to take the minimum number. So, for example, if we didn't see any A's, this array is going to get the 0th position in this 0th index in this array is going to get set to 0. So you don't have to worry about it, the indexes staying at the higher number that we put. That's a little hard to explain for now, but it'll make sense in a minute. So just to show you what we have so far, we just created an array with 26 slots, each holding number 100. So, and like I said, the reason we do that is because each of those slots are going to correspond to the lowercase letters. Then we're going to iterate over each word. Again, yeah, ES6 thing. I just like these shorter for loops. We're going to create that temporary array we talked about. Call it count. Fill that with 26 slots. We're just going to fill this one with 0 because we want it to update from 0 to 1 each time we see a letter, or 1 to 2, etc. So yeah, this is 26 slots, each filled with the number 0. And then we're going to iterate through each letter. Of each word, and we're going to say for each letter, we're going to update, take from 0 to 1 or 1 to 2, each character's corresponding position. And the way we get its corresponding position of each character is we do char code at, which gets us the character code, and then we need to subtract 97 from it. For example, if we had the lowercase letter a, its character code would be 97. So when we subtract 97, we get the number 0. And if we had the number 0 here, we would get the very first slot in count array. And then when we see that, we just increase that one time. So after we've done that for each character in the word, we then need to compare our temporary array to our master array. And if this doesn't make sense so far, don't worry. I'm going to pull out the whiteboard and get a little deeper into what we just did. And I'm just using the traditional for loop this time around. So we need to access the indexes, and we're going to do f.min. So what we're doing here, let's grab the whiteboard real quick. So basically, this is our master array. This is our temporary array for each word. And let's show you what I did right here. So as we jump into the word, we then jump into each letter. So for Bella, as we iterate over B, it would be character code 98, subtract 97, we get index 1. And we would then increase that from 0 to 1. And then fast forward, we've gone through all the letters in the word Bella. We then compare this temporary array, each slot in this temporary array, to our master array. So this gets set to 0, this gets set to 1, on and on and on. And so that's what we're doing with this math.min. We're taking the lower amount between the matching positions. And then at that point, so after we've done this for each word, and notice part of why the solution to this problem that we have, part of why it's so elegant is that this will take care of, for example, if we have, so let's take B, for example. When we see it here, we set it to 1. We see it again here, we set that index to 1 again. And then we see it here, it's 0. And so that third time around, we actually reset that from 1 to 0. So basically it says we haven't seen that letter B in all 3 arrays. So it takes care of that part of the problem. So after we get through every word, we now have this array filled with each lowercase letter's corresponding slot ticked up to how many times we saw it in each word. And from there, it's pretty simple to another for loop the traditional way. And now, let's pull back up the whiteboard and show you. Now we would have this master array with, and let's say, just real quick, that each, let's use the real example. So notice how L appears twice in each of these words. And let's say this is the L position, and it would have 2. We now need to create so our final answer is just going to be an array that we push the letters into. So let's create that real quick. Let's just say, and we're going to do a while loop, and we're going to say while so the first time through, we're going to subtract 1, and we're going to say, while that's still greater than 0, we are going to push the letter L. We gotta do from character code I plus 97 in order to get the actual lowercase letters character code. And so as that increments down, we do it one more time, and we get 0. Boom. We push L into it again, so we get the 2 L's. And at that point, all we gotta do is return this. Just to show you that it works, let's do and we would expect to get this out, which is indeed what we get. Just to show you it'll work for the other one. And we get COO, just like we expect. So it does work. It happens to be, since we're only iterating through our input array once, each letter, it's O of n, which is pretty tough to beat. I guess I can think of a way in which we could make it better, but it would be too laborious and probably not worth it. But for example, if we had 3 L's later on, if we only saw 2 here, we could just, and we saw 3 here, we wouldn't, or if we already saw 2 here, let's say we had a bunch of letters, we can stop iterating through for L. Anyway, that's gonna be too laborious. So this solution is pretty elegant and works well in O of n runtime. And yeah, I recommend watching the video again if that didn't make sense, but hopefully it did.